In 3.2G, I'm going to show you how to find the slope and y-intercept of the least squares regression lines if they give you the mean and standard deviation and correlation of the x and y variables. So the AP formula sheet is always going to have the standard format of the least squares regression line where y hat is your predicted of your x, and then you're given the y-intercept of A and slope of B. So what you would first do is actually compute the slope, and this formula is also on the formula sheet. To find the value of B, or the slope, which is right here, all you do is you take the standard deviation of y over the standard deviation of x, and then you times it by the correlation. Once you find that value, you can then go ahead next and find the y-intercept. To find the y-intercept, that is right here, the A value, it's this formula here. So you would use this to find that. All you need here is the mean of the y's minus the slope that we found over here times the mean of the x's. Let me show you how to use those formulas in this example. We're back at the 11 Honda SUVs where the x value is the number of miles in thousands, the y value stood for the mean asking price. If you find the average of the x's, the mean number of miles was 50.5 and the standard deviation number of miles was 19.3. If we look at the mean of the asking price, it was 14,425, standard deviation 1899. The correlation of this is going to be negative 0.874. So what we want to do to find the equation, if they don't give us the data itself, the raw data, we can use this formula. So we need to find A and B. I'm first going to start off by finding the B. Remember, the B is the slope, so I need the correlation times the standard deviation of y over x. So all I'm going to do is use this value here, this, and this one. When I do that, we just plug it into the formula, and what we have is our correlation, standard deviation of y over standard deviation of x, which gives us this final number of negative 0.86, which therefore is our slope. So then we can write partial our equation so far. This is what we have so far as our least squares regression line. Now the second spot, I want to find the y-intercept. So the formula I use for that is I have to find the A value from the formula sheet. So take the mean of the y's, which is right here, the mean of the x, which is here, and then the slope that we found from above. When you put that information into the formula, you're going to actually plot in your means and then the slope. You're going to get 18.786. And then from there, we can actually get the final equation, which is going to look like this. So this is the equation if we use x and y. If you use y hat and x, you must define the variables. If you choose to use the words, then you can actually write the equation with price hat is equal to this formula with respect to miles. So this is the equation for the least squares regression line. Now part B wants us to come on in and examine the residual for the 70,000 mile Honda, which cost $14,475. So we have this basic information. Remember, residual is observed minus predicted, or the actual value minus the predicted. So our actual value is 14,450. We can compute the prediction at 70,000 miles. I'm going to take 70,000 or 70 and put it into here and get the price. So when we do that, again, let's take the actual, which is right here at 14,450, and compute the prediction. The predicted amount is going to be our formula here, and I'm going to put 70 in for x, or for miles. When you do that, the residual is $1,710. What that is remember, it's showing that the actual is larger than the prediction. So the actual value is $1,710 more than what the predicted model would say. This amount, if we look at it also, this is the piece of data. That's the CRV we're looking at. Notice if I drop down a vertical line, this data point is above the predictor, which should make sense because the actual is larger than the prediction. If actual is larger than prediction, the actual scatter plot dot will be above the least squares regression line, and your residual will be positive. Keep a note on the flip side, if we were looking for an example, this particular data point, notice this one is below. So the actual is here, the prediction is here. In this case, we would get a negative residual. A negative residual means you sit below the least squares regression line. It is very important that you understand if the residual is positive or negative, if you sit above the regression line or below the regression line, because the AP board tends to have a multiple choice question relating to something like that concept.